If you were a geologist, how would you examine a rock for the first time? You might use a camera or notebook to record information about the setting where the rock was found. Then you would use a chisel or the sharp end of a rock hammer to remove samples of the rock. Finally, you would break open the samples with a hammer to examine their inside surfaces. You must look at the inside of a rock because the effects of ice, liquid water, and weather can change the outer surface of a rock. You can find interesting rocks almost anywhere. The rock of Earth's crust forms mountains, hills, valleys, beaches, even the ocean floor. When studying a rock sample, geologists observe the rock's mineral composition, color, and texture. Mineral composition and color. Rocks are made of mixtures of minerals and other materials. Some rocks contain only a single mineral. Others contain several minerals. For example, the granite in Figure 2 is made up of the minerals quartz, feldspar, hornblende, and mica. About 20 minerals make up most of the rocks of Earth's crust. These minerals are known as rock-forming minerals. A rock's color provides clues to the rock's mineral composition. For example, granite is generally a light-colored rock that has high silica content. Basalt, shown in Figure 3, is a dark-colored rock that is low in silica. But as with minerals, color alone does not provide enough information to identify a rock. Geologists observe the shape and color of crystals in a rock to identify the minerals that the rock contains. In identifying rocks, geologists also use some of the tests that are used to identify minerals. For example, testing the surface of a rock with acid determines whether the rock includes minerals made of compounds called carbonates. Reading checkpoint. How would you define rock-forming mineral? Texture. As with minerals, color alone does not provide enough information to identify a rock. But a rock's texture is very useful in identifying a rock. Most rocks are made up of particles of minerals or other rocks, which geologists call grains. Grains give the rock its texture. To a geologist, a rock's texture is the look and feel of the rock's surface. Some rocks are smooth and glassy. Others are rough or chalky. To describe a rock's texture, geologists use terms based on the size, shape, and pattern of the grains. Grain size. Often, the grains in a rock are large and easy to see. Such rocks are said to be coarse-grained. In other rocks, the grains are so small that they can only be seen with a microscope. These rocks are said to be fine-grained. Notice the difference in texture between the fine-grained slate and the coarse-grained diorite in Figure 4 at left. Some rocks have no visible grain even when they are examined under a microscope. Grain shape. The grains in a rock vary widely in shape. Some grains look like tiny particles of sand. Others look like small seeds or exploding stars. In some rocks, such as granite, the grain results from the shapes of the crystals that form the rock. In other rocks, the grain shape results from fragments of several rocks. These fragments can be smooth and rounded, or they can be jagged. Grain pattern. The grains in a rock often form patterns. Some grains lie in flat layers that look like a stack of pancakes. Other grains form swirling patterns. Some rocks have grains of different colors and bands, like the gneiss in Figure 4. In other rocks, the grains occur randomly throughout. Reading checkpoint. What does it mean to say that a rock is coarse-grained? How rocks form. Using color, texture, and mineral composition, Geologists can classify a rock according to its origin. A rock's origin is how the rock formed. Geologists classify rocks into three major groups: igneous rock, sedimentary rock, and metamorphic rock. Each of these groups of rocks forms in a different way. Igneous rock forms from the cooling of magma or lava. Most sedimentary rock forms when particles of other rocks or the remains of plants and animals are pressed and cemented together. Sedimentary rock forms in layers that are buried beneath the surface. Metamorphic rock forms when an existing rock is changed by heat, pressure, or chemical reactions. Most metamorphic rock forms deep underground.